This video, we're going to talk about finding the domain of a rational function. The denominator of the rational function cannot be equal to 0. So that's what we're going to be doing in each of these cases. We're not really going to worry about the numerator unless it has a square root or a log in it as well that would give us additional restrictions, or unless it's a complex fraction where there's a fraction divided by a fraction, we can't have the denominator of the numerator equal to 0. So let's go ahead and start with the first one. X plus 6 is our denominator, and it cannot be equal to 0. So we're going to subtract 6 from both sides. X cannot be equal to -6. We're going to write our answer in interval notation. First, I'm going to put it on the number line, -6 with a hole and shade everywhere else. That means that our domain is -infinity to -6, union -6 to infinity. Let's try this next one that has two factors, x minus 1 and x minus 2. That cannot be equal to 0. Now, when I set each factor equal to 0, instead of an or in between, since it's an inequality, there's going to be an and. So x minus 1 cannot equal to 0, and x minus 2 cannot be equal to 0. So x cannot be 1, and x cannot be 2. Number line, here's 1, here's 2, and it's allowed to be everything else. So we see that it splits it into 3 intervals, an interval from -infinity to 1, union an interval from 1 to 2, union an interval from 2 to infinity. That would be my domain. Let's look at number 3 that's not factored yet. X squared minus 25 cannot be equal to 0. So x plus 5 times x minus 5 cannot be equal to 0, means that x plus 5 cannot be equal to 0, and x minus 5 cannot be equal to 0. Subtract 5 from both sides here, add 5 to both sides there. X sorry, my pen stopped working for a second. X cannot be equal to -5, and x cannot be equal to 5. On the number line, there's -5 and 5. And that gives us a domain of -infinity to -5, union -5 to 5, union 5 to infinity. All right, let's try one more here. X squared plus 4 cannot be equal to 0. X squared plus 4 can't be broken up into any factors. Let's just show you that it's an irreducible quadratic. Anything that I square here, let's just look at the graph of this to confirm. X squared plus 4 looks like so. It's never going to be 0. So there are no bad points in the domain, no points to eliminate. So my domain in this case is going to be all real numbers. Just because you have a rational function does not mean necessarily that you're going to have to eliminate anything from the domain. If the denominator can never be equal to 0, then you're still going to have a domain of all real numbers unless the numerator also has some restrictions. Let's go ahead and look at number 5. X squared minus 9x cannot be equal to 0. We'll factor here, factor at the greatest common factor of x. means that x cannot be 0 and x minus 9 cannot be 0. So this one's already solved. Add 9 to both sides here. X cannot be equal to 9. Here's 0. Here's 9. Can't be either of those. Like so. So my domain is going to be negative infinity to 0, union 0 to 9, union 9 to infinity. Let's look at the next one. X squared plus 8x minus 20 can't be equal to 0. Let's try factoring this one first. Factors of 20 that have a difference of 8 are 10 and 2. We need a positive 10 and a negative 2 to add to give us a positive 8. When we subtract 10 from both sides here, x can't be negative 10. When we add 2 to both sides here, x can't be a positive 2. That gives us a negative 10 and a positive 2, but it can't be. It's allowed to be everything else. So our domain is going to be a negative infinity to a negative 10, union a negative 10 to 2, union a 2 to infinity. All right, let's clear the board and work on number 7 here. Number 7 says 3x squared plus 6x minus 45 can't be 0. Let's start off by factoring out that greatest common factor of 3 that I see. And because 3 is never 0, this is the same thing as saying x squared plus 2x minus 15 can't be 0. Factors of 15 that have a difference of 2 are going to be 5 and 3. I need a positive 5 and a negative 3 in order to get a positive 2. So x plus 5 can't be 0, and x minus 3 can't be 0. I'm going to subtract 5 from both sides. I'm going to add 3 to both sides here. Put it on the number line. Can be everything else. My domain is going to be negative infinity to negative 5, union negative 5 to 3, union 3 to infinity. Let's try number 8 now. Number 8 is the 2x squared minus 3x minus 5 can't be 0. Let's try our guess and check method. 2x squared has to come from 2x and x. 5 has to come from 1 and 5. If I put the 5 with the 2, that makes a 10. That seems too big to get a 3, so I'm going to put a 5 here and a 1 there. Now I need to try and get a negative 3, so that's going to come from a negative 5 plus 2 is going to give me a negative 3. So 2x minus 5 can't be 0, and x plus 1 can't be 0. 2x can't be 5, and x can't be a negative 1. We divide by 2 here. X can't be 5 halves, and x also can't be a negative 1. 5 halves is the same thing as 2 1/2. So here's negative 1, and 2 1/2 is somewhere up here. Can't be either of these numbers. So my domain is going to be a negative infinity to a negative 1, union a negative 1 to 5 halves, union 5 halves to infinity. Let's try number 9 now. 16x squared plus 48x plus 35. Wish I could pull out a common factor here, but I can't. So I'm going to have to try my guess and check method if I can. Signs are the same and they're both positive. You know, I'm going to have an x and an x here. I'm probably going to have 5 and 7 here to make 35. It's most likely what's going on. And factors of 16, let's see. So 4 and 4, that would make a 28 and a 20. That works. So this is a 28x and a 20x makes a 48x in the middle. So we're going to say that that's our denominator. That can't be equal to 0. So 4x plus 5 can't be 0. And 4x plus 7 can't be 0. We're going to solve here. X can't be a negative 5 force. And x can't be a negative 7 force. Negative 7 force is a smaller number than a negative 5 force. Negative infinity to negative 7 force. Union negative 7 force to a negative 5 force. Union negative 5 force to infinity. Now for a difference of cubes problem, just so we remember how to do this. Remember that this is x cubed minus 2 cubed, and our formula for a cubed minus b cubed is a minus b times a squared plus ab plus b squared. This one here is prime. There's no more factors to it. It's only got complex solutions to it. So this is going to be x minus 2 times x squared plus 2x plus 4. This one's never going to equal 0 anyways, so don't worry about that one. Like I said, that one only has complex solutions. X cannot be equal to 2 here. So my domain is going to be negative infinity to 2, union 2 to infinity. Yes, that's everything for this video. Next time we'll come back and talk about vertical asymptotes, which are closely related to this topic, but a little bit different.